Hello, guys. Welcome to Ramta Solutions, Grade 12 Physical Sciences Chemical Equilibrium Series. Today, we are looking at Le Chatelier's principle, the effect of changing concentration. Okay, so by now, I know you guys are grade 12s. By now, you know that concentration, what is it? You know what is concentration, right? You guys know that concentration is the amount of solute present per unit of volume, right? This you know. I'm just writing this to remind you. Amount of solute present per unit volume. All right? Per unit volume of solution. Oops, per unit volume. All right? So this is what you know so far. And you use the formula C equals number of moles over V, where this C, maybe let's begin with this N, is the number of moles in the unit mole. And this is volume. You were using cubic, or you use cubic decimeter. And this is concentration. You use the units mole cubic decimeter, right? You use concentration in the units mole per cubic decimeter. So pay attention here. The units of volume that you're using is cubic decimeter. Okay. So from this formula, you can see that we're saying concentration is directly proportional to number of moles, isn't it? So if your number of moles increase, your concentration increases, provided volume is constant. In the same way, if number of moles decrease, concentration will also decrease. Now, remembering Le Chatelier's principle, it said when the equilibrium in a closed system is disturbed, the system will reinstate a new equilibrium by favoring the reaction that will oppose that disturbance. Or simply, when a system at equilibrium is disturbed, the system responds by opposing that change or by opposing that disturbance and establishing a new equilibrium. Okay, so today we are going to look at effect of concentration change. Now we're going to use, for a reaction, we're going to use a reaction, let's say it is balanced, reaction A plus B giving us C. Oh boy. Equilibrium reversible reaction, right, plus, or rather, and D. Okay, now let's ask this. Now what happens when concentration of a reactant is increased? So increasing a reactant concentration, it does not matter if it's A or B. Okay, it does not matter if it's A or B. So we're gonna show you how we use low we're going to show you how we use Le Chatelier's principle to explain how equilibrium will react. Okay, so now let's see. We will say when concentration of the reactant is increased, follow me, when concentration of the reactant is increased, according to, I want you to follow this, according to Chatellier's principle, or according to Chatelier, okay, the system will act to oppose the disturbance. Okay, the system will act to oppose the disturbance by the disturbance, sorry, the disturbance by decreasing, right? By decreasing the concentration of the reactant. Remember, the disturbance here is increasing reactant concentration. Oops. Concentration of the reactant. Right? Now, what can reduce the concentration of the reactant? It is the forward reaction, isn't it? It is the forward reaction. Right? So in other words, the equilibrium will shift in the direction that uses the reactant. Okay. You guys got it? So the reaction that uses, when I say uses, in brackets, I will say in decreases. Okay, the reaction that uses or decreases the reactant's concentration is the forward reaction. Is there forward reaction? In this case, the forward reaction is favored. Right? The forward reaction is favored. Do you guys see that? The forward reaction is favored. Now, what happens when the forward reaction is favored? What happens? The amount of product, or products, in this case, our product is C and D, will increase. And amount of reactant in this case, A and B will decrease. Okay, now let's look at it. I'm going to highlight a few things here. Let me change the color. Which one? I think this one is better. I'm not sure. Let me see. Okay, yeah, it's better. Now let's see. You are increasing reactant concentration. According to Chatellier's principle, the system will act to oppose the change. Right? How does it do? System will act to oppose the change or the disturbance by decreasing the concentration of the reactant. When this happens, the forward reaction is favored. Why? Because the forward reaction uses the reactant concentration. The forward reaction is favored, and then amount of products increase while amount of reactants decrease. Right? As you can see, do you remember the graph I showed in the previous video? It's now working. Okay, so this is it. This is how we use Chatellier's principle. Now, how about we decrease? Remember, when we decrease, you're going to say to do the opposite. When you decrease, let me use a different color for decrease. Okay, and then I'm gonna use a smaller font size. So let's say now you decrease. Oops. Let's say now you decrease. Okay, So now when you decrease, what happened? Okay, when you decrease, let's see now. Decreasing will be the opposite. Decreasing will be when the concentration of the reactant is decreased, right? Is decreased. According to Le Chatelier's principle, the system will act to oppose the disturbance by increasing, right? By increasing the concentration of the reactant, right? The reaction that that produces, i.e., increases, right? That produces, i.e., no, this is too small. That produces, right? Instead of using, we're gonna say that produces or increases the reactants is the reverse. Is the reverse reaction. Now the reverse reaction is favored. What happens when the reverse reaction is favored? The amount of products decrease, amount of reactants increase. It's the same thing. Okay? It's the same thing. Do you guys see what you're doing? You just change the relevant weights here. Okay? You just change the relevant weights. Happy? I didn't want to repeat everything by writing down. It's going to take forever, but this is what we do. We just say, we use the opposite. Hence, the wording in red highlights when concentration of the reactant is decreased. Okay. Now, we have to go to when concentration of pressure is increased. Okay. Now we're going to when concentration of pressure is increased. Okay. Now let's go and see what's happening there. Let me just call it Roman figure 2. Increasing. Hold on. Did I use Roman figure 1 in the previous? So let's see. Oh, yes, I used Roman figure 1. Okay. So now let's see. Increasing concentration of products or increasing product concentration. Products concentration. Okay, let's see. So now what happens? So we're going to say when the concentration of the products is increased, you know that story. When the concentration of products is increased, when the concentration of products is increased, according to Le Chatelier's principle, or in English, according to Le Chatelier's, according to Le Chatelier's principle, the system will act to oppose the disturbance. The system will act to oppose the disturbance by what? By decreasing the concentration of the product. By decreasing the concentration of the product. By decreasing the concentration of the products. I want you guys to remember that these reactions can proceed in both directions, right? So, the reaction that uses the products, right? The reaction that uses the products, the reaction that uses or decreases whatever the case may be. The reaction that uses or decreases the product is the reverse reaction. Is that reverse reaction. Therefore, that means the reverse reaction is favored. The reverse reaction is favored, isn't it? The reverse reaction is favored. Now, what happens when the reverse reaction is favored? Amount of products decrease and, by the way, I should say this, products, maybe let me write it in brackets. In this case, we are working with C and D. And amount of reactant and amount of reactant. In this case, it was A and B. What happens with them? They increase. Right? Oh, I messed up here. Amount of products decrease and amount of reactants increase. Right? Remember, guys, what happens when there's a disturbance? The disturbance was to increase amount of product. Equilibrium will shift to decrease the amount of product. So when we decrease amount of product, it means we are forming reactants. Okay? So like I did with decreasing. So when you decrease, you will say, I'm just going to change the colors. Okay? So when you decrease, let me just say decreasing products concentration. So when the concentration of products is decreased, according to Chatellier's principle, the system will add to oppose the disturbance by increasing. Remember, system does the opposite by increasing the concentration of the products. The reaction that increases uses, I'm going to say produces. So that uses or increases the products is the forward. In this case, it is the forward reaction. The forward reaction is favored. Amount of products increase, and then amount of reactants decrease. Right? So in black is when we say amount of products increase. In red, when amount of products are decreased. So this is Chatellier's principle. Remember what it does? It says if you increase, the system will try to decrease. Okay, the system will do the opposite. Right. So this is Chatellier's principle with regard to concentration change. So see you next time when we look at pressure change. Bye-bye.